Greetings and welcome in this video lecture. In this video lecture, I'm going to discuss a problem related to truss, and the method which I'm going to use to solve this problem is joint method. During this process, I will explain few fundamental concepts required for solving this problem. A part of this, I will also discuss the problem which was asked in GATE. I am Rahul Verma, working as assistant professor in Department of Mechanical Engineering at ABES Engineering College, Ghaziabad. So what is a truss and what is joint method actually? What does joint method actually do? The primary purpose of truss is to support. So they are structures. And our issue in this lecture, which I'm going to discuss, is to find force in all the members of the truss, so that while designing, I can or we can make a structure which is strong enough to sustain the load. There are many more methods to solve it. I will be discussing joint method in this situation. For solving problem using joint method, the truss should be statically determinate. And to ensure that the truss is statically determinate, there is a very simple rule which we follow. M equals to 2j minus 3. Let us understand each part of this equation one by one. M here represents the number of members in the truss, and J represents the number of joints in the truss. If M equals to 2 times J minus 3, then the truss becomes statically determinate, and it is possible for us to find the force in members of the truss using the method of Newton, that is concept of equilibrium. Okay, so what are the equations of equilibrium and what type of force system we are going to deal with in this method? The force system will be coplanar non-concurrent force system, and therefore the equations of equilibrium are of the type sum of all forces in the horizontal direction, sum of all forces in the vertical direction, and sum of all moment about the axis perpendicular to the plane must be equal to 0. Why is this so? Because we are working in a coplanar non-concurrent force system. Now let us come to the problem itself. This problem was asked in GATE 2019. A truss is composed of member AB, BC, CD, AD, and BD, as shown in the figure. A vertical load of 10 kilonewton is applied at joint D. Find the magnitude of force in the member BC. So we are interested in finding the force in the member BC. We are interested in finding force in the member BC. Is that okay? Let us check whether it is statically determinate or not. So how many members are there? There are 1, 2, 3, 4, 5 members. In total, there are 5 members in this truss. And how many supports do you find? You can see that at joint A, we have a pin support. And at joint B, we have a roller support. So if we draw the FBD of this structure, what does the FBD look like? It will look like this. And this particular value is 10 kilonewton. B, A, oh, this is D, okay? A, this point is B, and this is C. This reaction is the horizontal reaction at A, because this is a pin support, and this is the vertical reaction at A in the Y direction, and this is the vertical reaction at C. The reactive force are given a symbol by cutting the arrow. Now, You can see that there are four members. Okay, so we'll check the value in the formula, check each part in the formula. M, how many members are there? 5. You can count one by one. 1, 2, 3, 4, and 5. How many joints are there? So you can see 1, 2, 3, 4. So J equals to 4. M equals to 5, and 2J minus 3 will be 2 times 4 minus 3, which is 8 minus 3, and this will be also 5. Here we can see that the number of members and 2J minus 3, both values are 5. So this kind of truss is statically determinate, and we can find the value of force in each members of the truss if we want, using Newtonian method. Now let us go for finding force in member BC. Before we find the force in member BC, there are few assumptions normally we make. I am making an assumption which is important for you to understand, that we want all the members to be in tensile load. Okay, we are keeping, this is the assumption which I am keeping. I am assuming that all the members of the truss are having tensile load. Okay, and then we have to find the reactions at the support. As you have seen in the FBD, this figure is somewhat symmetric, and therefore we can use the concepts of symmetry, and I will leave for you to find the reaction. I will leave for you to find the reaction using method of equilibrium. Okay, I will use the concept of symmetry. Because I don't have any horizontal force except RAX, this means that RAX will be 0. Okay, so the first thing, this I am doing by using the method of symmetry. Summation F x equals to 0. I have only one force, RAX, and no other force is present. So reaction in the horizontal direction at joint A is 0. Now I could go for summation Fy and summation Mz also, but I am using the concept of symmetry, and I am directly writing that Ray and Rcy both will be equal, and it will be 10 by 2. The load will be equally distributed. So it is 5 Newton. Is it kilonewton? Kilonewton. Is that okay? Now let us go to the joint C. Okay, we are going to joint C. While drawing the joint, see, this is what is unique. We have using the joint method. So we draw the FBD of each pin. I am taking the pin C and I am drawing the FBD. While drawing the forces, while assigning direction to the force, make sure that all the forces are moving away from the pin, so that it ensures that my assumption is correct, that all the force in the member are tensile in nature. If the value comes out to be negative, then it is compressive. Is that okay? So let us give name to it as per the name. I'll follow the alphabetical order. So this force I am calling it as FBC, right? And the other one is I'm calling as FCD. And this one is 5 kilonewton. Okay. And what is the angle between the two? The angle given is 45 degrees. You can use the concept of Lami's, because now this becomes a coplanar concurrent force system. But I will use the concept of resolving the force and then equating it to 0 using equations of equilibrium. So summation Fy equals to 0, right? Taking upward direction as positive. So what can you write? F of force in member CD sine 45 plus 5 kilonewton. This will be equal to this will be equal to 0. Okay. Now, from the above equation, we can easily see that it is minus 5 by sine 45 kilonewton. This minus sign signifies that member CD is in compression. Okay. Now let us move to the member BC. So now we are taking horizontal component of the force. Sum of Fx equals to 0, taking left side as positive. Okay. So we can write F of BC plus F of CD cosine 45 equals to 0. We are interested in finding FBC. This will be minus of F times CD multiplied by cosine 45. Okay. What is the value of FCD that we can refer? It is minus of minus 5 divided by sine 45 multiplied by cos 45. What do you observe? That cos 45, we know that cos 45 and sine 45 have the same value as 1 by root 2. So they will become 1. And minus 5 into minus 5 will become 5. So what is the force in member BC? 5 kilonewton. The positive sign, what does it signify? It signifies that the member BC is in a state of tension and it is experiencing a tensile load. Okay. So let me summarize what I have did. The first step is to check whether the truss is determinate or not, to apply Newtonian method. Once you have judged that the truss is determinate, then you can go for finding the reactions at the support in some of the cases. That reaction could be found by many methods. You can use the concept of equilibrium, or you can use the concept of symmetry, as I have done over here. And then I have used joint method. While using joint method, I draw the FBD of the pin, the concerned pin, and then apply the condition of equilibrium for coplanar concurrent force system. Using this method, you can find force in the desired member, and the positive sign will show that the member is in tension, and the negative sign will show that the member is in compression. Okay. So this is a book which I have used to deliver this lecture. This is one of the best book, I think so. So you should read it, or you should try to read it. Thank you very much.